Namaste everyone. Today we will discuss about distance and displacement. Distance. Generally we use the term distance to find distance between two cities, distance between your house and school, distance between your house and the market. So what distance actually means? So distance between two cities. Let us suppose city A and city B. The distance between these two cities is 60 kilometer when you go by road. So the same distance between these two cities when you go by train, this is by road or by bus on road. So distance between these two cities when you go by train, so here the distance is 68 kilometer. So these two cities are the same and distance should be same. So why there's a difference when we go by road and when we go by train? So here, whenever we use this term distance, it is nothing but the length of the road. So the length of the road that you travel is the distance between these two cities. In the case when you travel by the train, it is nothing but the length of the track between these two cities. So whenever we express any quantity in distance, it is nothing but you are going to express the length of the path between those two places. Oh, on the other hand, we have displacement. So displacement between your house and the school. Let me take this example. That is your house, and we have here somewhere your school. So when you go from house to school, maybe the road goes this way, the path goes this way. So the distance you need to start and you need to move along the road. So whenever someone asks you the distance between your house and school, you are going to express the length of the path. Maybe let us suppose it is 5 kilometers. Then what is displacement? Displacement means irrespective of the path, the shortest distance between your house and the school. So in a particular direction. So there need not be any path here. So it's a straight line when it is drawn from your house. It's an imaginary one. So it's the shortest distance between your house and the school in a particular direction. So in that direction, the shortest path is called displacement. For displacement, it need not require to be having a path or a road. So it's an imaginary one, or we can say it's the shortest in a particular direction. So displacement. And that's the difference between distance and displacement. So let me put the definition of distance and displacement in front of you. Mm, Distance. So distance is the actual length of the path traveled by a moving body. So let me draw the path here. So you are traveling along a straight road from A to B and then from B to C. That's a straight road. So this is 4 meter and that is 3 meter. So the total distance traveled by you if you start here initially and that is your final position. So the distance you move is nothing but the path along which you traveled. So this entire path we are going to mention. So 4 meter plus 3 meter, that is total 7 meter is the length of the path. So the distance traveled by you is 7 meter. On the other hand, I will give you the example of displacement. Displacement is the shortest distance between the initial and final positions in a particular direction. So I'm going to put the same example. So take the same example. Mm, Taking the same example, so you travel by the path A and B in a same straight direction, and that is the C. So this is 4 meter and that is 3 meter. So this is your initial position and that is your final position. You started here and you end up at C position, traveling from A to B and then B to C. Now what's the displacement? Displacement is always the shortest distance between initial position and the final position. So this distance between A and C you need to find. So that shortest path you need to find. So how to find the shortest path? So for this we are going to take the help of Pythagoras theorem, taking this as a right angle triangle, and this we are imagining this one as a hypotenuse. That should be the hypotenuse. So AC square should be equal to the side square, sum of the side square, AB square plus BC square. That is AC equal to under root AB square plus BC square, which is equal to under root you are going to put 4 square 3 square, which is equal to root 16 plus 9, that is equal to 25, which is equal to 5 meter. So AC is 5 meter. The displacement is 5 meter. Now displacement in most of the time, in most of the cases, displacement is always less than or equal to distance traveled. So displacement in this case you have less than the distance traveled. Distance traveled is 7 meters, whereas displacement is 5 meters. Okay, now we'll take some differences between distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity because it requires a particular direction. In a particular direction you are going to consider. Distance is simply the length of the path. No need to worry about the direction in which the vehicle or a body is moving. So distance in most of the cases is positive. So most of the, it's always positive. When a body moves, the distance you will have 60 meters. You can't put negative 60 meters. Whereas displacement is positive in the case when it is moving from initial to final in that particular direction. It is negative when it is moving from initial to final, if that is the direction of motion. So when it is moving in the opposite direction. So in this case we are going to consider a negative displacement, that is if the body is moving in a direction opposite to the one which it has to move, then this direction is considered as negative, so the displacement will have a negative value. So displacement can also have zero value. So displacement can be zero in what case? If that is your initial position, object has moved to the final position, and then after reaching the final position, if the body has returned towards initial position, something like, I'll give you this example. So your school bus from the school, it starts at 8 a.m. in the morning, then it picks up all the students going to different places. Then after picking up all the students, it will return back to your school at 8:30 a.m. So that means for 8 a.m. to 8:30 a.m. your school bus may be covering 25 to 30 kilometer distance, which is equal to the length of the path that it has moved. Whereas at 8 a.m. it is at school, and at 8:30 a.m. it is again in the school. In that case, the initial position and the final position is your school. So displacement becomes zero in such a case, whereas distance travel will have a positive value of 25 kilometers, which it has actually covered in that half an hour. I think you got my explanation for the displacement having zero value. In most of the cases, distance is greater than displacement. In most of the cases, you can distance is greater than displacement in most of the cases. So I have given this example. No, in that example, distance is 7 meters and displacement is just 5 meters. So one more, I'll give another example. When is distance and displacement equal? So distance and displacement can be equal if the object or a body is moving in a particular direction, in a straight line. So that should be a straight line. So it should be something like a linear motion moving in a straight line and in a particular direction. But if the object moves in the opposite direction, in such a case, displacement will not be equal to distance. So both will be equal. The possibility for distance and displacement to be equal is the path should be a straight line and the object should be, or the body should be moving in the same direction. So otherwise you will have distance is always, except this case, the remaining cases distance will be greater than displacement. Okay, the next one, I'll put the table of differences between distance and displacement in front of you so that you can check this. So in this table I have mentioned the differences between distance and displacement. So the first difference is the definition of both. The second one is distance scalar, displacement vector. Distance is always positive, displacement can be positive, negative or zero. So distance is always greater than or equal to in one case. Otherwise displacement will be most of the time less than or equal to in one case. So SI unit for both is meter, and both of them are for now represented by the capital S. When we are doing the numericals, we are going to put it as capital S. Now let me take few examples from your NCERT. Maybe the time may not be sufficient for me to cover all the example questions in this video, but if possible I'll cover at least one or two questions. An object has moved through a distance. Can it have a zero displacement? Yes. Support with an example. So some example you can give. If an object is thrown to a certain height and then it returns back to the same position. So if an object, when it is thrown to a certain height, that is when it is thrown upwards and it returns back to the same height. So traveling upwards to height h, so that's the height. So distance traveled, here in the case distance traveled will be equal to going h plus coming down h, so 2h, and displacement in such a case will be equal to 0 because the initial as well as the final positions are the same. So displacement is 0. So the example, in this example we can put object returns to the same height when it is returns to the same position when thrown upwards. So in such a case, one more example I'm going to give for this displacement. Let me draw this. So I'm going to draw one circular path. So in this circle, so let me consider this one as an initial position I, and that is confusing. I'll rub this. So that is our initial position I. So the man started running from this position and has completed one round. So after completing one round, his final position will be the same. So distance traveled after completion of one round will be equal to the length of the circumference. So it is equal to 2 pi r. Whereas displacement in this case will be equal to 0. So this example, man after completion of one round in a circular track. In such a case, both distance and displacement will be the same. Okay, thank you for now everyone. The next numericals I will solve in the upcoming video. Have a nice day. Stay home, stay safe. Bye.